and electricity likes a potential of difference. She grabbed the nozzle, you saw the spark jump from her finger onto the nozzle and start a fire. Goes down into the gas tank of her Jeep and it starts going down the hose. From what I hear, in fact it was John Fralla that gave it to me, from what I hear it took the whole station out. Because a check valve failed and it got to the underground tanks.
Wow.
Little mushroom cloud. So that's totally believable. In fact, if you go to the gas stations these days, it'll tell you, touch your, ground yourself before you start grabbing any of the metal.
How do you ground yourself?
Just touch metal.
Oh, touch me.
Just get out of your car, like the pole that holds the thing to wash your windows with, just touch that. Now you've basically come electrically neutral, and now you can grab the nozzle and there shouldn't be a static discharge.
Touch metal.
Yeah, I used to discharge myself by petting my brother's Rottweiler and lighting him up. That didn't go well. Alright.
That nozzles, they have a new plastic that protects it too anyways.
Yeah, but you still should ground yourself. I'm waiting for the guy to throw himself on the ground. I'd be like, that's just too funny. Alright, now, I have a tool here that's designed to force open this valve should it electrically fail. Okay, it's called a manual override tool. And what it does is I got a stem that comes down here, pushes on the top of this valve and opens it up. That's all it does. Now, there's a procedure for installing that. You have to do some status and safety checks so you don't take to get this tool in here, I have to take this tool out. So if I have a valve that will not energize and open, I have to remove this tool and put the override tool in to push it down. Now, if I should remove this tool while this valve is stuck open and not know it, I've got tank pressure coming at me. Not a fun place to be. So you have to do some status checks prior to pulling out that override tool, or you could have a very unwelcome surprise. When I use this override tool here, I have to replace the valve because on top of this, on top of here, there's a very small O-ring that tool damages. And if you look down in the board, there's the little O-ring that's been pulled out of its place, and now it's going to disrupt the valve. I have to replace the valve. That's no biggie. They're only $325 each or something. That's what it is. Lines and connectors. Okay, most of these are swedge lock design. Okay. Loosen up when the fittings are on their initial tightening. You have a gauge. They give it to you, gap gauge. So when it comes from the factory, the gap gauge should not fit between the fitting and the body of the fitting, the cap and the body of the fitting. If it does, too loose. Work. When you reuse it, yeah.
Now, going back to those tanks, just another question. Who decides whether a tank is still good or whether a tank needs to be condemned?
A certified tank inspector, we have a bunch, we certify.
Well, it's just not the regular mechanics that do that?
The regular mechanic can inspect the tank, but if he sees damage, like a scratch or a gouge, then the tank has to be inspected by a certified tank inspector so he can determine the status of that.
Or how deep that scratch is or whatever.
Exactly. So anybody can inspect the tank. So during a PMI, your mechanic can go up there and he can look at the tank, and he can look for damage, scratches, anything that indicates there might be a need for some service, and then turn that report over to a detailed tank inspector, and he can go up there and ascertain damage. Make sense? The tanks themselves have an expiration date. You know, like that milk in the back of your fridge. I didn't know they put cottage cheese in gallon containers. Sorry. Yeah, that's bad. All right. Yeah. Okay, my initial filter, the primary filter, we used to call it the pipe bomb filter, but people would get nervous when they hear pipe bomb mentioned in a public place. But it looks like a pipe bomb. Okay? You have to depressurize the zone, so you close the quarter turn tank valve, you run the vehicle out of fuel, and you simply loosen this up, spin it off, replace the coalescing filter, put it back on, tighten it up. What's the mic? I have no idea. I have no idea. Couldn't tell you. Huh?
That'll be your home.
That'll be your homework, exactly. Yeah, I don't know what it is. I don't know. If you break this thing loose and you have to keep wrenching and keep wrenching and keep stop, you didn't pressurize it or depressurize it. We have a mechanic who's done that 3 times now. Do you know who he is? Oh, he doesn't. He seems to think it's funny.
It looks like at the bottom of the filter, that notch.
That's
It's
exactly
so
what that
you
is.
can
There's a
take it
special
off.
tool we have.
Yeah,
Okay?
just like the engine has a.
Yeah. Yeah. I mean, they try and make it idiot-proof, but then again, you know, we've had the remedial idiot training.
I'll take my screw.
Yeah. No, this individual has pulled it off under pressure. And it fires down, bounces all over the place. Last I heard it was 3. I haven't seen the 3, but you got a great union, gentlemen. You know, work safer, work union.
Damn.
Mm-hmm. Love that shit. Good thing he's not an electrician.
He hasn't got written up for it.
Oh,
huh?
I'm sure he has.
Oh, he has. What is the amount of points on something like that?
I have no idea. I know not to be around. If it gets to be upstairs and I'm still alive, we got problems. Now we got the secondary filter. It looks like an oil filter. It spins on, spins off. Okay. I don't know what the micron rating is on that one either. I don't. It is what it is. Okay. Now, primary fuel pressure sensor. I got some videos here. I'm just going to let them run if they're here. Okay, here we go. Play.
Fuel enters the fuel module from the OEM supplied fuel tanks at the top rear of the fuel module through the fuel inlet fitting and flows into the fuel pressure regulator chamber. Fuel flows to the fuel inlet pressure sensor. The minimum fuel inlet pressure is 70 psi, 483 kilopascals, and the maximum fuel inlet pressure is 150 psi, 1034 kilopascals. Fuel enters the fuel pressure regulator, where the fuel is regulated for normal operation to 65 to 73 psi, 450 to 500 kilopascals. An air line from the air inlet connection in front of the throttle plate actuator provides the boost pressure air to the fuel pressure regulator. This boost pressure air is used to control the fuel pressure regulator.
Now,
Fuel from the fuel.
that's from the vehicle into the Cummins fuel control module. All right. So you have a fuel line leaving the bus body going into the engine's fuel control module. That's the initial. That's the second pressure drop. Actually, the initial pressure drop comes from the ITT regulator. Okay. Takes it from tank pressure, 3,600 pounds, down to approximately 150 pounds. So if I open up my door, my fuel door, I'm going to see 2 gauges. One's going to read tank pressure, whatever's upstairs in the tank, and the other's going to read pressure, regulator pressure. And it should be about 150 pounds. If it's more than that, you've got one of 2 problems. What are they?
You got a bad meter?
Got a bad gauge
Bad
or
meter.
bad meter. Okay. That's when you get inside out. You log on to Cummins. You log on to Insight. You see what the pressure sensor on the regulator is telling you. If it says 150, you got a bad gauge. If it says what the gauge says, you got a bad regulator. Make sense? Okay. So the controls the fuel pressure, and air from the inlet connection goes to the back of the regulator. So if I need additional fuel, boost pressure will work on the back of the diaphragm of the fuel pressure regulator and increase fuel pressure to meet the air demands. You got a carburetor, you got an accelerator pump in your carburetor, it does the same thing. Okay? So once it passes through the fuel module regulator, and continue to flow to the shutoff valve. The shutoff valve is an on-off valve.
Fuel from the fuel pressure regulator then enters the fuel shutoff valve. This valve is a normally closed valve that opens when commanded by the PCM.
That's all it does. It's
After the
just
fuel
on
leaves
off.
the fuel shutoff valve, it flows past the fuel outlet pressure temperature sensor. The output of this sensor, combined with other sensor outputs, is used by the ECM to check the air-fuel ratio.
So if I got a crank but no start, I can use that sensor after the fuel flow valve to tell me if the fuel flow valve actually opened. Right? I go on there and I fuel pressure sensor, crank the engine over and see if that sensor reads pressure. If it doesn't, my fuel flow valve did not open. Continue to flow through the open fuel flow valve, past the fuel outlet pressure, temperature sensor. So we're looking at the temperature and the pressure, so the computer's starting to calculate density. Okay? And calculate air-fuel ratio.
After the fuel flows past the fuel shutoff valve, it travels to the gas mass flow sensor. A flow passage in the fuel module has a restriction that forces approximately 10% of the fuel to flow past the gas mass flow sensor wires. The gas mass flow sensor calculates the amount of fuel flowing to the engine by measuring the cooling effect of the fuel flow across two electrically heated wires. The sensor then sends a signal to the ECM proportional to the amount of gas flowing past it. The ECM uses this signal to make adjustments to fuel flow into the engine. Fuel flowing past the gas mass flow sensor wires rejoins the remainder of the fuel flow. The sensor is a hot wire anemometer that measures the amount of power required to keep an electrically heated wire at a constant temperature. As more fuel flows over the wire, more power is required to maintain the constant temperature.
And your mass airflow sensor works under the same theory. So as I flow fuel over those wires that are set at a preset temperature, and no, I don't know what that temperature is, it's just a temperature, the flowing of the fuel over the wires will have a cooling effect. And as I add more amperage to the wires to maintain the original set temperature, the computer reads that draw, that amp draw, as fuel flow. However, if I take more amperage to keep the wires hot, one can infer I'm flowing more fuel. If all of a sudden I have a drop in amperage to keep those wires at that preset level, one can infer I have less fuel flow. Okay? So it's a hot wire anemometer. That makes sense? So after the fuel leaves the shutoff valve, past the pressure temperature sensor, will flow to the gas mass flow sensor. That's where the computer starts looking at my fuel flow. Approximately 10% of that fuel is sampled. Theory being if 10% is flowing past the wires, the other 90% is flowing at the same rate. Okay? Calculates the mass of the fuel, volume, and sends that effect, or that value, to the ECM. As the flow increases, the cooling effect increases. The cooling effect increases, the amount of current necessary to keep the wires hot increases, and the computer sees that as a large amount of fuel moving into the engine. Okay? It's a hot wire animal. Now, the question comes up, well, what if that fails? Okay? Then we will use a virtual or a calculated volume for that. The engine won't run well, but it will run. Of course, you'll have a stop engine, check engine light on, and maybe some other codes related to the pressure sensors downstream that are reading values outside of the range they should be compared to the other sensors. This is how sometimes you got to look outside the box. You know, it's a domino thing. If something fails up here, you're going to get codes all the way downstream of that. So you have to look at what do all these codes look at and what could be causing the code. Okay. Now, after we leave the gas mass flow sensor, we flow to the fuel control valve. This is the pulse width mod. This is the throttle. All right. So when you step on the gas, okay, you're putting an input into the ECM that says I am requesting more power. Now, the engine's ECM is going to look at all of this data. Temperature of the engine, temperature of the coolant, boost pressure, manifold temperature, gas mass flow sensor, gas mass pressure, gas mass temperature, barometric pressure. And it's going to decide how much power it can give you based on the conditions it's operating in. And then it's going to modulate this fuel flow valve by pulsing the valve on and off rapidly, changing the relationship of the valve to the opening. Idle versus wide open throttle. Okay?
Fuel then enters the fuel control valve. This valve is a normally closed valve that opens when provided with a pulse width modulated signal from the ECM.
That's all it does. So you have a fuel flow valve, which is basically the door to let fuel into the fuel control module. Then you have a fuel flow control valve that after the computer looks at it, the fuel's pressure, the fuel's temperature, and the amount of fuel coming into the engine module, it will now meter the amount of fuel allowed to flow physically into the engine's intake manifold. All with me? Now, we have a mixer. Not your KitchenAid, this is a different mixer. Okay? After the fuel flows past the flow control valve, it's going to enter the horizontal vein of the mixer, where it mixes with the incoming air, metered by the throttle plate. And the incoming air, its mass, its volume is also measured by an air mass flow sensor, which works very similarly to the fuel flow sensor, the mass fuel flow sensor. The mass airflow sensor looks at the cooling effect the air has as it goes over two heated wires. Now these two components are not interchangeable, but they do work on the same theory of operation. So now the engine's going to know the inlet air temperature, the inlet air pressure, and the inlet air volume. And it's going to know the inlet fuel pressure, inlet fuel temperature, and the inlet fuel volume. And it's going to calculate what all that's going to look like when we mix it together in the mixer. It will know its volume, it will know its temperature, it will know its density. Okay? This is how we get a more precise metering of the fuel for emissions. Okay? And to a certain extent, fuel economy. Also in this mixer will be a passage to allow exhaust gases to be recirculated into the inlet of the engine. The inlet being the airflow inlet. Because this is a gas motor, we mix our fuel and air outside of the combustion chamber. Now, when we get into emissions, we'll talk about this a little more, but let me just give you kind of the Reader's Digest version of this. The theory, and I know a couple of people in New Flyer that still think that exhaust gases are put back into the engine to reburn the fuel and oxygen, when in fact that's not the case. They are completely wrong. And the thing is, I respect these gentlemen highly, so I don't argue the point with them. Everybody's entitled to be wrong, except me. I'm perfect. Not. I couldn't even say that with a straight face. My exhaust gas, or my combustion chamber temperatures are upwards near 2,600 degrees Fahrenheit. That's a wee bit toasty for me. That's a lot of sun. That's like SPF 1 million. Okay? But I have to control my combustion chamber temperature, because if I get too hot in there, I'm going to have oxides of nitrogen, combine that with sunlight, and we get that beautiful downtown Los Angeles, we call it smog. Let's see, Jeff, you're from California, right?
Not original.
Oh, you're from New York.
Yep.
We pack a cat. Okay, if you were a...
That's more like a Boston accent, by the way.
Just saying.
Norton! Kenny!
Jeff would know.
Jeff would know. Well, if you were in California in the 60s and 70s, we had what they call stage 1 smog alerts,
Yeah.
where, oh, you're from,
Yeah,
Okay.
I remember it.
you remember those. Your Ranch Cheryl contributed to that.
I
Still does.
I'm exempt from smog.
Yeah, oh, I'm sure my lungs will appreciate that.
Yeah. My lungs aren't exempt.
Exactly. But what I'm saying is that was that, and correct me if I'm wrong, it was a kind of a brownish yellow haze that would set in
Yeah.
over the city. You want an example of smog, watch some of the opening scenes of Dragnet. Right? That's smog. This was the city, no, that's smog. The city's underneath it. Okay? Well, the prime culprit on that was oxides of nitrogen. Okay? So the way to reduce that is to reduce the combustion chamber temperatures. Okay? Back in the day, we had the smog pump, which pumped fresh air. Actually, that was for the cat. Okay? They came up with a way of actually providing air conditioning to the combustion chamber. So what they would do is they would take exhaust gases, run the exhaust gases through a cooler, and get the temperature down to about 700 degrees on these exhaust gases, and then they'd stick it in the combustion chamber. Well, if you look at the difference between 2600 degrees and 700 degrees, that's like blowing AC in the bad bear.
Yeah.
And now, these exhaust gases they're called inert. It's an inert gas. In other words, it will not release heat because it will not combust. Okay? So since it doesn't release heat, it doesn't add to the combustion chamber temperature, it actually cools it down. And this is how I control my smog emitting emissions. Now, since we lowered the combustion chamber temperature, we created another problem. Now, since my temperatures are cooler, my ability to combust all of my fuel is not so guaranteed. And so then we have our O2 sensors and our catalytic converters, or if you're from the south, our Cadillac converters. If the Cadillac converter broke, still Ford.
And Mike, but we're only using that like above 25 miles an hour or like quarter throttle or something like that. Like it's not using
Yeah,
that
well-
performance,
Yeah, under light load, because remember, I can't put low pressure exhaust gases into a high pressure manifold.
right? Yep. You blow your boost right out the exhaust.
Well, no, I would have my exhaust backing up into my EGR valve and backing up back into the engine. But when the engine is under maximum load, it's burning its most efficient, so I don't need to put exhaust gases in the combustion chamber. But if I'm idling, or what is my British counterpart? If I'm motoring down the motorway, if I'm cruising down the highway under partial throttle light load, the engine's not running efficiently. So that's when my EGR valve would be open, and I'd be attempting to cool the combustion chamber. Okay?
Fuel flows into the front horizontal vein of the mixer, where it is mixed with the intake boost air that is entered from the throttle plate actuator.
Okay, so we pretty much vaporized that. Now, our engine is by no means high performance, not by any stretch of the imagination, because that manifold design is very inefficient. Okay, it's just a passage that gets flooded with a gaseous air-fuel mixture. And so I have all these intake valves opening, and everybody's got a hand out reaching for a chunk of that mixture. And by the time number 6 comes around, that mixture is not the same as what went in. So number 6 and number 5 may or may not be running the same air-fuel ratio as number 1s and 3, or 2. So those two cylinders tend to run hotter because they tend to run more oxygen than fuel. At least that's what I've heard from some engineers. Now, whether that's correct or not, I have no way of verifying that. But just by looking at that intake design, it's basically a cavity. It's like, I'm going to just fill this bucket full of water and you all take what you want. Okay? Now,
The fuel-air mixture then mixes with the EGR gases that have entered the rear vertical vein in the mixer from the EGR control valve. The system is designed to only allow approximately 30% of the EGR gas flow into the mixture.
No, I think somebody asked.
Leaving the mixer, the fuel, boost air, and EGR mixture is then routed through a passage in the fuel module into the intake manifold in the head and onto the intake valve for each cylinder.
So one has to wonder that the fuel-air mixture leaving the mixer into the manifold, does it stay the same as it fills the manifold? Cummins says absolutely.
Depends on how good your mixture is.
Well, there's a lot of variables in there. There are many variables in there.
Do they get carbon duct like they do on the diesel in CNG?
No. CNG is carbon, it's like carbon light. It's like diet carbon.
That's a problem with diesel, those mixers. just-
Well, because diesel fuel is heavily laden in carbon molecules. It's like CH26, whereas CNG is like CH04. Not a lot of carbon in it. That's why it makes a great fuel if you're looking at it strictly from an emissions point of view. It's an outstanding fuel. But from a performance point of view, it's not all that, because it has a much lower heat value than diesel and gasoline. So consequently, when it does combust, the pressure it exerts on the piston isn't as much as the same volume of fuel if it were, say, diesel. Because it has a higher heat value, when you combust it and releases the heat, it puts more pressure on top of the piston. It's been said that when a combustion ignition engine, a diesel engine, ignites in the cylinder, almost instantaneously you have a little over a ton of pressure striking the top of that piston. 2,000 pounds.
They call it like a plasmic state, because there's so much compression in the fuel injected, it starts to burn.
Alright.
So it almost changes state.
How much compression is the motor? In the chamber, how much is it, about 11 to 1 or
No, these gas motors are about 9.5 to 1.
in these dummies? Oh,
About 9.5 to 1. Yeah, it's just like your car, 9.5 to 1. So again, the motor was built around its emission level, not around its performance. Okay, not around the performance, emissions and fuel. Now, consequently, there are some improvements in that engine that make it a little more efficient, but then there are detractables, like EGR. Okay, EGR, exhaust gas recirculation, does not improve the engine's performance. In fact, it takes away from the performance. Because I'm filling the cylinder with a gas that is not going to add to the heat generated by combustion. So that area that is containing that inert gas could be containing an air-fuel mixture that could add to the pressure developed onto the piston when I light it off, right? This is why if you go out and buy a new Dodge Cummins pickup today, it's 6.7 liters. They had to make the engine larger to offset the power loss of all the emissions equipment. Okay? Not that, now I'm sure,
5.9 or something?
5.9 was the size of the first Cummins B series they put in the pickup starting in 1985. Okay? And the first engines were making 160 horsepower. It's pretty detuned. Okay? Now, I'm sure that 6.7 is making more horsepower and torque than the 5.9 is, because they had to tweak it to get more horsepower and torque, because they wouldn't be able to sell it if they said, yes, it's a bigger, more expensive engine and makes less horsepower than the one you've got now. So that's not going to sell. So they probably made improvements on the injection system to get some more horsepower out of it. But the prime mover, and this comes to me from Cummins, Leroy Carr out at Bloomfield. He says, we didn't make it at 6.7 because we wanted to. We made it bigger because the power loss that 5.9 had suffered because of all the emissions made it unattractive as a truck. Oh, I want to buy that Dodge making 110 horsepower. So if you're going to do that, you might as well buy a gas motor. Right? So they had to make the engine larger displacement wise to offset the loss. And they had to make the cooling system larger to offset the heat rejection generated by the cooling of the exhaust gases. Okay? They had to modify the turbocharger to accommodate exhaust gases getting put into the intake manifold. There were a lot of things they had to do to get this thing to maintain the output of the pre-smog motors. Or why would anybody buy one? I'm gonna spend $90,000 on a truck that I can pull a smaller trailer with, because it doesn't have the horsepower. But wait, you get leather seats. Yeah, it better be good, because I'm gonna be in them longer. All right, questions? Then have a nice day, go where you need to go, and we'll see you Wednesday. Probably lab day, so wear your best sandals.
Can we get a quiz? So we know where we're at.
I can probably do one. I don't normally, I could, because I have a lot of material, not a lot of time. A quiz usually kills about half a day. But if you want, I can make one up for you, you can take it at home and we can talk about it.
Yeah.
Okay, I can absolutely do that.
That's a good question. That I have to look up. Yeah, it's not gonna be.